Hello everyone, my name is Iris, and I'm here to talk to you about the technology that I developed during my PhD, which is using AI to automatically detect archaeology on Earth observation data. And so a bit about me. My computer is really trying to be very slow. Let's see if it's okay. There it goes. So I am an archaeologist by training. So I did a bachelor's and master's in archaeology. And during the master's, I was really interested in these automated technologies and how we could maybe use that. And it was very much a topic that was unexplored, and a lot of criticism was around it. So people really didn't think that this would ever be possible. So what I did during that master's was look at the data sources that we have available to us, and what are the manual limitations to interpreting these, and what are really the values that we can get out of values we can get out of doing an automation study on it. So yeah, these sources have been really well discussed already in this talk, so that's really amazing. I don't have to focus too much on these data sources that we could be using to automatically detect archaeology. So there is the crop marking and the aerial photography that we can see archaeology that is buried underground, and then we can have the earthworks that are above ground that we can detect with LiDAR technologies and such. But the need for automation that I saw was that in these manual interpretations of these data sources is very dependent on a geographical bias that we hold. So there is different geologies, whether you can see the crop marks on chalk or clay, is a completely different return that you can get. So you need a lot of information to make your interpretations, and also like whether there is any crops growing there, the difference between the crops that are growing there, show archaeology differently, the time of year, and then also like weather conditions that come into play. So that's one element, but then the other element of bias is the human bias. So how much expertise does the interpreter have, and what is their knowledge, their interests even. Like if you're really interested in Roman archaeology, you're more likely to miss the prehistoric stuff. And so also like if you are flying around in an actual airplane rather than looking at the whole area as satellite imagery, as we can do now with Google Earth, but like previously you would have to fly, and still people are doing this, flying in an aircraft, and then you're also very dependent on your flight paths and your pattern of flying. So there are all these biases that are there that maybe with more automated technologies we can solve something. So just another one here is the data processing bias that also were already discussed in the previous talk. So there is the infrared light. So as humans, we can only see the visual spectra, which is the red, green, and blue. But there is the infrared, which holds more information that maybe we can capture. And a lot of satellite images are able to capture that, even in up to 16 bands of different, like infrared, ultraviolet, and go beyond. So there's a lot more data out there that we know how to process, and every time we process this data, you have to make choices on how you highlight the data, and that was also talked about with regards to the LiDAR. So in this LiDAR example here at the bottom, you can see the ridge and furrow being illuminated with the hill shading from different angles, and you see a completely different picture there. Revealing. And then finally is of course the time aspect. Like there's so much data out there, and potentially like even with all the data that we already have today, with all the satellite imagery data that is being captured, maybe there is so much archaeology in there that we don't just know about because we don't have time to look at it all. So a computer could work tirelessly like through the night, through the weekend, and not get also maybe bored over lunchtime, and it just keeps going at the same rate with everything. So that's the thing. AI can be used as an average of all human experts. So even where experts disagree, like the AI can become like an average of everyone, and it's able to interpret the raw data format. So rather than having to process all the data in ways that we can see it, it can look at a digital terrain model without having to visualize it in different ways, and then it can come up with its own what it finds is most important to look at in the local relief, for example. So There's another thing, like you can stack both LiDAR data and satellite imagery and historic mapping, like all on top of each other to get that information from it. So there's a lot of like hypothesis, hypothetically we can do a lot more even than some of the things that I will talk about now. So the technology that we use for this is called deep learning, and it's the same technology that is in the self-driving cars today. So it's being used for lots of different applications, for text recognition, speech recognition, even to detect these objects that are moving around. So like a self-driving car would need to do that. What I'm focusing on is image recognition. So that's a bit of that. So what it goes into something like this, you can see this really big network there on the image. That's called a deep neural network or convolutional neural network. And what we give it is a lot of images and labels with those images. So in our case, it might be a lot of images of burial mounds. And we know that they are burial mounds, so they get that label. Then what is meant to do is classify those burial mounds in different classifications that we have given it. So in goes the burial mounds with our labels, and out goes them into categorized groups. So internally, rather than us saying you need to look for circles, the circles needs to be this big, you need to look for all these things, what it actually does is internally it learns what features it needs to come to the conclusion. So it will learn that it needs to find circles. It will learn that it needs, all these different elements to find an object. So with this face recognition, you can see that then in the early layers of this network, it learns all these lines and edges and color blobs. But further on in the network, it learns more of these combinations. So it gets little like corners maybe. And then like in this example with the face, you can see the different types of noses that people have, the different types of eyes, proportions and stuff. And the more detailed it gets, the deeper into the network. So it's kind of similar to how the human visual cortex works. So that's a bit of the background on the technology, and so we've been using that in my PhD then to automatically detect archaeology on LiDAR data. And so in goes the LiDAR source, and then also the labels that we have for things we were looking for. So in this case, it was roundhouses and small cairns, and that goes into the training network. And then out comes the object that we are interested in, which is in this case a roundhouse that wasn't previously known. So we've done this study with the Historic Environment Scotland on the Isle of Arran, where they've done a big manual survey as well. So they've manually looked at all the LiDAR data. So it's really intensively surveyed the area, and they've given us those locations to train the AI and apply inference on the rest of the island as well. So we've got quite a small set of data for a deep learning approach. Most have been trained on millions of images, and we have a very small data set. So there's a lot of tricks that I had to do to make this really work. But it's been successful. That's the conclusion so far. So you can see here then as well, they went into the field to verify some of these locations, and you can see that if you walk on this surface, there's a lot of bushes, and it's really difficult actually to see the archaeology. You could be standing on top of the roundhouse and not even see it, which is difficult. When you just look at the LiDAR, it looks so obvious, but in the field, it's really difficult to interpret even the sites when you're straight on top of it. So the results that came out of it were really good. We did find 200 false positives. So we were really interested in maybe if these wrong detections could be sites that we didn't previously know of. And so one of these examples I just showed you, Historic Environment Scotland officer Dave Cowley thought was really, really interesting because it's a location that he thought, oh yeah, that's a roundhouse. But his team actually did see as well this feature on the LiDAR survey that they did. They looked at it and they thought, okay, maybe this is some sort of an enclosure, but we're not very confident. So they sent a team out to survey it. And you can see the red line is what they walked over it. And as they walked over it, they couldn't see the object and they said it was natural. But then the AI came back and said, no, I actually think this is a roundhouse with high confidence. So And then in the end, it came back into the records as being a roundhouse. So we actually did this for lots of different sites, and we found that 130 were actually previously unknown sites. So it was really successful to find new ones there. And the remaining false positives that were there were maybe sites, or they had like a good rationale for false positives. So here are some examples of that, where at the top we have some examples of these were correctly predicted, but they had very low confidence from the AI. And you can see that like they are not the most obvious roundhouses. So it makes sense that the AI wasn't fully confident that these were sites. Then on the second row below that, you can see that all these examples were missed by the AI. So these were all false negatives. So they are very, very faint roundhouses. Definitely examples where maybe a manual interpreter could miss them, or like could find them still. So then the interesting row is the third row, where those are the examples that the AI found and that the manual interpreters missed. So that's really fun to see come back. And then the lowest row is where the AI found things that were actually not roundhouses. So an interesting burial cairn was found by the AI, very high confidence, but definitely not a roundhouse, but another interesting object. And then another thing is the golf bunker, which is a really annoying to us because there are many of them in golf courses. And so we've really disregard then golf courses in our results from now on, because we find them a lot. They are this nice circular shape and made by humans, but not interesting to us. And then some of these other examples are more like geographically, geologically issues that we find. So paleo channels are derived, create a very curved pattern that is interesting, but not for this research. And then some peat ponds and things. So we've got similar results back from the shieling huts and the small cairns, but I will not focus on them now, but that research can be found elsewhere. So then coming out of the PhD, it was there's so much value in this research. What shall we do with this next? Do I go into academia, continue my research in the university, or do I maybe think about doing this commercially? Because there's a lot of potential for the AI to actually work across the country and not just in small areas for research. So that's what we are doing now. I've started this company called ArchAI. And we really want to position the product that we've created at very early stages of planning permission. So when they're just trying to, when a construction company is just thinking of planning a road or planning where they're going to build new houses, at that stage where there's normally no archaeological research going on, they can have a little bit more insight of what archaeology might be there before then they continue with an environmental impact assessment and have to do further manual verification. So that's kind of what we are where we're at now, and we've had some good success so far with different grants that we were able to attract. I mean, I also had to learn a lot about how to run a business and how to do that. So I've had different opportunities from accelerators and also from the Royal Academy of Engineering to help me with this. And currently we are part of the European Space Agency Business Incubation Center to also start working with satellite imagery, which is really fun. And we are working with commercial trials now as well with the Forestry Commission and the National Trust. So we're making good progress now, and not just on that aspect, but also on the technology. So we've gone from detecting bounding boxes around objects to really being able to segment whole things. So on the right, you can see 4 images of different enclosures, like hill forts, and around it, you can see some of the ridge and furrow that we've picked up, linear earthworks, mounds, and the quarries are picked up quite well also. And then on the bottom, middle left, you can see that also we're now able to detect deserted medieval villages. And so it's fun to see those results coming back. It's becoming cleverer and cleverer. The more we train it and the more information we give it to learn from. So we've tried a little bit with satellite imagery, but that is still a challenge that we want to address this year. So it's very different. Like this, the manual challenges at interpreting satellite imagery are also there for the AI. So it's like, it's very variable based on the crop and the growth stage. There are visibility issues with satellite imagery, so there might be clouds or haze. And yeah, there are archaeological sites that cross multiple fields. So you're really dependent on like what crop is growing in what field at what time. And so I think that's, I don't know how much time I have, but I think this is a good point to leave it at this.